ideas. And we start with the power 0. And we already know based on the properties of the exponents, correct? Anything to the 0 power gives us what? 1. And sorry, I need to turn a little light on myself. Can you see when I turn the light on? Therefore, this any binomial to the 0 power, because we have only one base, is going to be what?
1.
1. Way to go. Way to go. Now again, using the properties of the exponents, anything to the first power is exactly the same. Is your base, correct? Therefore, x plus y to the first power is going to give us what? Nice. But now there are formulas that you must memorize. And these two are the focus. So we call it a square of binomial and a cube of binomial, correct? And today you will understand why we memorize these formulas. So as I already wrote, can you see I wrote it using a and b, as I wrote using x and y. Does it matter? No. What matters? That you represent and understand what is your first term is and what is your what? Second term in the binomial. And then you expand. So when we expand, we verbalize first term squared. If it's plus, it must match with the sign of the second term. 2 times the product plus second term squared, correct? I will discuss next formula and then we will look for a pattern. Because higher exponent, more complex your expansion is. So let's look at the cubic formula, cube of a binomial. So the formula is, because I memorized everything, yes? So it goes, first term cube plus 3 times first term squared times second plus 3 times first times second squared plus second cube. And now let's look for patterns, correct? Because if I understand the pattern, then I can expand whatever binomial I have without thinking too hard. And let's see, what have you noticed? We are looking at the first term, second term, we are looking at the powers, and we are looking for patterns. So let's see, I will guide you, yes, because it's evening, you are tired. Okay, everyone, try. If I have exponent 2, correct? How many terms do I have?
3.
Way to go. If I have exponent 1, how many terms in an expansion do I have?
2.
If I have an exponent 3, how many terms do I have in my expansion?
4.
What have you noticed? What is the pattern?
You're going to have one more term that you're going to have.
N plus 1.
Way to go. Way to go, because the common mistake in this formula, this is what students are writing. They are writing a squared plus b squared to minus. Can you see? And it tells me that they never understand the pattern behind. Yes? Because if my exponent is 2, can I have 2 terms?
No.
No, and it's not equal. So, now let's follow the pattern. If I have a degree 4, how many terms do I need to have?
5.
Excellent. Okay, so we will have 5. If I have degree 5, how many terms am I going to have?
6.
Amazing. So this is pattern number 1, correct? Number of terms. We will summarize everything. Now let's look at the exponent of the first and last term. So I'm talking about this is first, this is second, correct? Okay, first and second. So can you see that the first term always represent by the first term to your degree, correct? And the last term is represented by the second term to the same degree. Yes?
Right.
But now let's look at the degree. Let's look at the second term. What is 2 plus 1? 3. What is 1 plus 2? 3. Can you see? So what have you noticed? Let's look here. This is 2, this is 2. What is 1 plus 1?
2.
2. So what is another pattern that we are looking for?
The exponent will always be equivalent
Way to go.
in each term.
Way to go. Because you need to add, to find the degree of this term, you need to add the powers. Yes? So the sum of all of the exponents everywhere needs to be equal the degree. Yes? Good, good, good. So how many patterns?
2.
Now, how can I remember the formula? Because I verbalize the formula. I'm looking for another pattern. And now everyone, let's look. If I'm looking at the degree of the first term, that is x right now, correct? What is happening with the degree? We started with 3, then goes what?
Down.
0,
Then what?
1.
Then what? Way to go. Now let's look at the degree of the second term. What is happening? What is the degree of y here?
0,
0. Then what?
1,
Then what?
2,
Then what? Way to go. So I make a conclusion. The degree of the first term goes what? Down. The degree of the second term goes what? Up, correct? And the sum of the exponents in every term needs to be equal the degree of your binomial. Are we good? Okay, now let's try. Fourth one together, yes? Good, good, good?
yes,
Okay. So I will help you with coefficients, but variables you are going to figure it out. So what is my first term here? According to the patterns. X to the fourth. Now plus, we will have coefficient 4. Now let's figure it out exponents. X needs to be to the what power?
30,
Nice. Y need to be to the power what?
1.
1 because there is 0, correct? 0, 1, correct? Moving on. Plus 6. What should be the degree of x?
2,
What should be the degree of y?
2,
Nice. Plus 4. What should be the degree of x?
1,
What should be the degree of y?
3,
Way to go. Plus
y to the 4th,
y to the fourth. How many terms do I have?
5,
5. Degree plus what? 1. Yes? Everyone, can you see? We just discussed many patterns. Yes? Can we do it again? Can we do it the same thing with the fifths? Yes?
Mhm.
I will help you with coefficients. Okay, let's try. First term to what?
5th,
5th.
To the fifth. Yes? Then we will have 5. And again, can you see this coefficient is equal to your degree? Second coefficient is equal to your degree. 5. X to what power?
4th.
Way to go. Y to the power what?
1.
1 plus 10. X to the power what?
3,
Y to the power
2,
plus 10. X to the power what?
2,
Y to the power
3,
plus 5. X to the power
1,
y to the power
1,
plus y to the power what?
1.
And again, can you see the pattern works? Degree plus 1 term. So now let's look at another pattern, because all of this are the square of the sum, correct?
Oh,
Yes, yes, yes. But if I will have minus, and I'm going to add it here, I'm going to change the color. If you have minus anywhere, every even term will become negative. And this formula already takes care of the sign, and this is what you need to pay attention. So if I have a negative over here, pay attention, then every even term becomes negative. So if this is negative, then I immediately know this second, fourth, and sixth are going to become what? Negative. And why it is important? Because I don't need to worry about negative base to this power. Formula takes care of that. And I'm looking for the pattern. So if I will look at the fourth power binomial and I will have a difference, what do I need to remember? every even term will become what? Negative, correct? It means fourth and what? Second, yes? Now let's look at the cube. Every what? Even term will become what?
Negative.
Negative, therefore second will become negative and fourth will become negative. Now let's look at the second degree. If I have a difference, correct? Can you see? My second term is going to change the what? Sign.
Sign.
Yes? And more patterns you know, yes? More you will understand common sense, you will pay attention, and you will avoid a lot of mistakes, and you can do it faster. Good, good, good?
Yes.
Okay. So now let's talk about coefficients. So we talk about degrees, correct? We talk about signs. We talk about patterns. But now let's talk about these coefficients. Coefficients are values in front of your terms, correct? In front of the variables. How can I memorize them? How can I remember them? Again, when you solve a lot of problems, you will remember by doing them. But there is a Pascal triangle. It's a French mathematician who discovered this pattern. Okay, so this Pascal is a French mathematician. Again, if you are interested in the history of mathematics, look him up. So he discovered this pattern, and we use it in algebra class to help students to remember these formulas. If you forgot, draw a Pascal triangle. So what do we need to see? What is the pattern? So you start with 1, you create this Pascal triangle, and then every term in the next line is going to be equal to the sum of the consecutive terms above. So over here, 1 plus 2 gives me 3, 2 plus 1 gives me what? 3. Can you see? Then if 1, I start with 1, then it would be 1 plus 4 gives me 5, 4 plus 6 gives me 10, 4 plus 6 gives me 10, 4 plus 5 gives me what? 5, correct? So I immediately know coefficients in my next line. Can I write them? Yes, so 1 is the outer, what would be here?
6.
Way to go, what should be here?
15.
What should be here?
20.
Again what?
15.
And
6.
and 1. Correct? And then you immediately know degree of the first term goes down, degree of the second goes up, and you are done. Yes? Good, good, good? Okay. So this is your pattern that will help you. So now let's try. With the coefficient arranged in this way, each number in the triangle is the what? What did we just do here?
Sum.
Is the sum, and I will put in red, is the sum of the two numbers directly above. It's too blurry, correct? Are you doing something? Sorry guys. Look, at the end of the semester and I'm still not a friend with this machine. Right there. Okay, perfect. So this is your pattern. That every coefficient arranged in a way that the number in the triangle is the sum of two numbers directly above, correct? And you create like a triangle every single time. So now let's try. We are going to use common sense, yes? Look for patterns. This is the key word for today. And we are going to expand this expansion without looking. Yes? Good, good, good? Okay. So we start. Now let's discuss the pattern first. How many terms am I going to have? 7. Yes? What would be my first term? 1, correct? What would be my last term? 1, yes? Then you go from out inside. Then second and second before last are going to be your 6's, correct? Can you see it's symmetrical? Then previous was 5 and 10 that gave us 15. Again, it's symmetrical for 15. And 10 plus 10 gave us what? 20. Now, when I know coefficients, the rest we are looking for the patterns of exponents, correct? So we are going to go extremely fast. Let's go. We have x to the power what? 6. Because it is plus, and I'm going to highlight, so you pay attention. If it's plus, all terms are positive. If it's minus, what will happen?
Even.
Even terms will turn
Negative.
negative, and you don't need to worry about carrying negative signs in and negative bases to put parentheses around. So plus 6x to the power what? 5, y to the power what?
1.
Nice. Plus 15, x to the power what?
4.
Y to the power?
2.
Nice, pay attention. 5 plus 1 gives me 6, 4 plus 2 gives me 6, correct? Plus 20, x to the power what? 3, y what? Cube. Plus 15, x squared, y what? Fourth? Yes. Plus 6, x, y
5.
what? Fifth. Plus y to the
6.
6. Amazing. Yes, yes, yes? Okay. Now, question is, do I constantly need to remember everything? What about if I want to find this coefficient when my degree is 59? Do I need to create triangle with 59 rows? Or 60 in this case? No, I don't. So question is, what is the fast way, correct? Like we did arithmetic and geometric sequence. If I have a 377 term, am I going to sit and add my difference 375 times? Of course not. Or geometric sequence, am I going to multiply? Of course not. So we are looking for a shortcut. And this shortcut, it's another new idea. It's factorial. So this is a more efficient way to find these coefficients, to find any coefficients. And coefficients are these values in front of each term, correct? So let's talk about this factorial. What is the factorial? It's a expanded product in descending order. So n factorial in general way written as whatever value is here, you start with n, and then you decrease it. N minus 1, n minus what? 2, then you go to 3 times 2 times 1. Also remember, this is the rule, that 0 factorial gives you 1. And I will give you an example so you will understand. For example, I have 7 factorial, correct? 7 factorial, it's a shortcut. But in order to calculate it, I'm going to expand it. So it would be 7 times 6 times 5 times 4 times 3 times 2 times what? 1. And then I can calculate this product and it will give me whatever big number we have. Yes? But can you see, it's a shortcut, like multiplication. If I have 2 plus 2 plus 2 plus 2 plus 2 and keep going, then no one is going to write like this, correct? We created a multiplication, 1, 2, 3, 4, 5, 6, so it will be 2 times 6, correct? But if I change the same thing, and I'm doing now multiplication, I don't want to sit and do the same thing. So we created an exponent as a shortcut of what? Multiplication, correct? Can you see? That now again, it's a new shortcut. If I have 2 times, let's say 22 times 21, 20, and keep going till 1, no one is going to spend time doing this, correct? I recognize the pattern, because this is a key word for today. And I can write it as 22 what? Factorial. And there are a lot of key strokes or key functions on a calculator that will help you to calculate it fast. Everyone say woohoo. Yes, so we are going to practice today algebraic way, yes, because if you forgot the keystrokes, or if your numbers are so big, then calculator doesn't have capacity to calculate. Can you see? And then it will just say, cannot calculate. And students don't know what to do if they don't have skills, even if it's easy and you can just reduce fractions. Good? So we are going to practice by hand, and we are going to practice on a calculator today. So, let's try. How can I now use this factorial to find a coefficient for whatever term I want? Because there is another pattern, correct, that we are looking for today. And the formula is the same for a combination. Remember, you learn permutations, combinations, yes? Yes, yes, yes? So when you choose a group within a group, correct? Yes, group within a group. For example, I want to choose any 3 students to be my right hand, correct? Volunteers. So then order does not matter. But as soon as I'm putting ranks there, I will say the student with the highest grade, the student with the second highest grade. Then you are going to change, and it plays a huge role. Which one? So for this particular part, we are going to use combinations. And there is a button, again, on the calculator we will practice today, and a formula that you need to memorize. Formula you need to memorize. So, formula is a combination, and I'm choosing group within a what? Group, correct? Now let's look. So, if I see this, it means that I'm choosing 2 people out of 10. Okay, everyone pay attention how it's. I'm choosing group of what? 2, yes? Group of 2 out of what? 10. This is how you are going to verbalize. Yes, you are choosing 2 numbers, 2 books, 2 whatever, 2 cars on the parking lot out of 10. And we can rewrite it in a variety of ways. So this is way number 1, this is how calculator is set up. Now way number 2, how we are going to set it up. It's a vertical format. So this is format number 1. This is format number what? 2. Yes? Which one calculator takes? First or second? First. Correct? So you need to know how to read it. And the formula, if we are going to use it algebraically, is going to be written like this, and we are going to practice today. The key is to expand and reduce. How to reduce fractions, we practice, correct? Okay, let's try. Evaluate binomial coefficient, evaluate each binomial coefficient. Yes? So, also pay attention according to the formula that you have non-negative integers because you are choosing objects, number of objects, correct? Within a group, and they cannot be negative. They cannot be negative. Okay, let's try. Slow. I will go algebraically, then I will introduce you to calculator, correct? So, according to this, please. I'm labeling. This is the M, this is my R. So, I'm choosing, and I'm going to rewrite it as a group of 2 out of how many?
6.
6. So, we go from one symbolic representation to another. Now, according to the formula, in order to calculate this combination, I go n factorial, so 6 factorial, over 2 factorial, times the 6 minus 2 factorial. Any questions so far? And now I'm going to teach you what to do. And I'm going to write in red. So simplify. 6 factorial times 2 factorial times 4 factorial. And in order to calculate it fast, you are going to pick the largest one. The largest factorial. And you are going to expand to the largest factorial in the denominator to reduce. Okay, one more time. Which one am I choosing? Largest or smallest?
Largest.
Largest. So what does it mean? My largest is 4 factorial, correct? Now I'm going to expand numerator till 4 factorial. I start 6 times 5 times 4 factorial. And I stop. Why am I stopping? Because now I'm going to do what? Reduce. And this is the key word. Expand the numerator to the largest factorial in the denominator to reduce. This is the goal. Factorial, factorial. On the top and on the bottom, the largest, correct? So we will end up with the smallest numbers, smallest coefficients. You are going to cancel it out. Now this is a common mistake. Pay attention. Students see 2 on the bottom, 6 on the top, and they continue reducing. You cannot, because this is now a coefficient, this is a number, this is a factorial. So what you need to do, now you need to expand the smallest one. Expand the smallest factorial. Because you need to have the same units, correct? So now when I expand, I will have 6 times 5 divided by 2 times 1. Now when I expand it and I don't have factorials anymore, we are going to reduce as much as you can. 2 goes into 6 3 times 5 gives me 15. How are we doing? Okay, let's try again. Let's try again. Let's do this one on the right, B. So we are choosing 0 objects out of group of what?
8.
8. Can you see I'm changing the format so I can verify my answer on the calculator if necessary. Now according to the formula, 8 factorial divided by 0 factorial divided by 8 minus 0 factorial. Now everyone pay attention, 0 factorial equals 1, correct? And 8 minus 0 factorial will give me 8 factorial, correct? So I can cancel them out, correct? And we will have 1 on the top, 1 on the bottom, this gives me 1. So my answer is 1 over 1 gives me what? 1. Okay, let's try another one and then we will summarize formulas that you need to remember. Let's try 10 out of 10 and pay attention to the patterns, correct? So we will rewrite as a combination of 10, choosing 10 out of group of what?
10.
10. Then we have a similar situation, 10 factorial times 10 minus 10 will give me 0 factorial, correct?
Yes.
10 factorial cancel out. We have 1 over 0 factorial gives me 1 over 1 gives me 1.
1.
How are we doing? Good? Okay, next one you try by yourself. Next one you try by yourself. Follow the formula, remember, expand numerator to the largest factorial of the denominator, so you reduce and your numbers becomes the smallest possible. How we doing? Done? What did you get? Ready to go?
Yeah.
Ready to go. Good, good, good. So, now, if you have a calculator, depending on the format, it works differently. So I'm looking for calculators that have newer, can I borrow you? Thank you. So depending on the calculators that you have, let's now practice. So we will verify our answers using a calculator. So I will start with the newer model. If you have this one, you go straight forward. Mass, you can go to probability. And under probability, you have a button for permutations and a button for combinations. We need combinations. And it immediately will give you a format to plug, correct? So you can plug, for example, first one, group of 2 out of 6. And then you click enter, and it's going to calculate everything for you. Good, good, good. But if you have a calculator like I have, it works differently. Look, if I click on the combination, can you see it does not give me a lot of things. So first, you need to plug your values. Make sense? So what are you going to do? And let's see, because I did it long time ago, let's see. So I think first you need to plug 6. Then you need to go mass, and you need to plug your combination, and then 2. Can you see? Completely different keystrokes. So you need to practice, because if you will go, for example, to math centers, they don't have these new calculators. So you need to know keystrokes, otherwise you're going to just not know what to do. And then you click on it. Yes? Okay, so I'm going to put over here as a button on the calculator, and you need to practice whatever calculator you have, correct? So calc, you're going to go mass, then you go to the right and you pick probability. Let's see how it's written. Probability, and you go down, and according to whatever you have, yes, you need to make a note for yourself. If you should first plug N, then button, then your R, correct? Or you have a calculator that gives you a format to plug in. How are we doing? Good, good, good? Okay. So let's move on. Can I move on now? Any questions about how to use a calculator? Okay. So no questions. Let's try. So let's summarize now, correct? Everything that we discussed, and we are looking for patterns. This is the key word. So there are going to be how many terms? If my degree is n, general form, wait it up. The first term, it's always going to be x to the power, correct? And the last term would be y to the what? Power. In succeeding term with exponents are going for x go down, for y are going to go up by 1, correct? The sum of the exponents in every term needs to be our n. We already practiced, correct? Now the coefficients of the terms are written in a form. X to the power r, y to the power n minus r. But we are going to use this format when you expand, because otherwise it's backwards. So we are going to focus on this format. Yes? Because x goes what? Down. Not y goes down. Can you see? Then order would be different. So we are going to focus on this format where x goes down, and we can find the coefficient using combination, correct? Choosing R out of n, group of n, or remember the way how we are going to write, just to confuse you, so you will not know what to do, yes? Different symbolic representation as n of R. Okay, any questions so far? So now we are going to use these ideas and using these binomial coefficients, these formulas, and look for another pattern. Yes? Look for another pattern. So the pattern is described in this theorem one more time. And these are, as we noticed, everyone pay attention, I highlighted this part. I will highlight. This is very important that you understand what we are choosing, because n will stay the same, but your r will be represented by the degree of your y, of the second term, correct? So over here, degree of y is 0, correct? Over here, degree of y would be what? 1. Therefore, to find the coefficient, this is the degree of y. It must match. So to find the second coefficient, in this case it would be sort, correct? Because this is 1, correct? So this would be second degree of y, but the sort term in your expansion. Yes, yes, yes? It's going to be combination, and you are going to choose group of 2 out of n, correct? Then you move on. Again, pay attention. It must match the degree of y. You will choose number of combination, or choosing group of 3 out of whatever your degree is. And you keep going, and degree of x goes down, degree of y goes what? Up. Yes, yes, yes? And now I'm going to write what you need to remember, that we already practiced on the other side. If you have a situation where you have n combination of 0 terms out of n, it's always 1. Or you have n of n, then it's also 1, and you don't need to calculate it, just much shorter, correct? Because we already proved using algebraic skills. How are we doing? Good? Okay. So now we are going to look at another format, because this is the sum, correct? I can write it as a summation. I can write it as a summation, and again, pay attention. This is for plus, yes? But if I will have a difference, what will change? What will change?
The even.
Way to go. The signs of the even term. So this is first will be positive, second will be negative, third positive, fourth negative. This is positive, yes, la la la, and we will pay attention. Even terms are negative. So now, because it's a sum, I can write it as a summation, yes? I can write it as a summation of a form from 0, because we are going from degree of y, correct? Start with 0, till n, till the last term, and we will have n, r, bless you, number of combination of choosing group of r terms out of n, and your exponents, x to the power n minus r, y to the power r. So this is the general formula how to find this sum. And pay attention to the question, because we can ask you to expand and find the sum, or we can ask you to find one specific term, then you don't need to do all of this work. Yes? Good, good, good? Okay, let's try. So applying the binomial theorem, let's look. Everyone, what is my power here?
9.
9. Therefore, how many terms am I going to have?
9.
10. So step number 1, we will have 10 terms. So I'm going to show you what I did for myself because I love math problems. I don't love to write essays. So I did everything by hand, and I will show you that I even needed to blue piece of paper because it was not enough. So I did everything algebraically, and I'm just going to show you. Can you see it? Keep going. I needed to attach a paper for myself. That this is a puzzle, yes? Because I did everything using formula for combination, and I did every calculation by hand, yes? So you are lucky in America that you have a graphing calculator with all of these features. In Europe, we are not allowed to use them. You cannot even buy them. So you need to have skills, correct? So I will just show you how complex these problems can be, but we are going to go short way, correct? We are going to set everything up. This is the key, by hand. And then you are welcome to use a calculator and the buttons that we learn on a calculator, how to simplify it fast instead of doing all of this reduction and expansion for every single combination. Okay, are you happy? Okay, good. So I will not going to put you through this, but this is what I do. I never go by the book because I teach you from my heart, correct? Okay, but this is, if you would like to explore, do it by hand. So let's try. Everyone together. To expand it, we are going to look for a lot of patterns, yes? And pattern number 1, 10 terms. Now we look for coefficients and we look for exponents. So first term would be what?
X,
Ready to
and
go.
I.
Plus, and everyone pay attention. I pay attention to the symbol, correct? Yes, yes, yes? Because it's plus, it means I don't need to worry about signs. Every term will be positive, correct? Now we go. To find the coefficient for the second term, and very often, in order to not to mess it up, start with the exponent. So it would be x to the 8th, y to the what?
1.
First. Therefore, now when you know the exponent, you are ready to set it up. 9 and 1. Do you agree?
Yes.
Yes, yes, yes? So this is the degree of y. This is your degree of the binomial. Are we good? Moving on. For the next term, the power of x goes down would be what? 7. The power of y goes up would be what?
2.
Therefore, now I will set up a combination of choosing 2 terms out of what?
9.
9. Now we are moving on. Next term, x power goes down, correct? Y power goes what?
6.
Up. Therefore,
Oh.
to find the coefficient, I follow the pattern, yes? And stays the power of your binomial gives me 9, and r is the power of your r gives me 3. Am I done?
No.
No, I keep going. So plus, it's a big problem. I start with the exponent. X power goes what? Down, y power goes up, and we set it up as a combination of finding 4 terms out of 9. Do you agree? Plus, x goes down to the 4th, y goes up to the 5th, therefore, combination, sorry, put as a fraction, sorry, 9, 5 out of 9, keep going, x cubed, y to the 6th, therefore, 6 term out of 9, plus x squared, y 7th, therefore, 7 out of 9, plus x, y to the 8th, therefore 8 out of 9, and the last one will give me y to the power 9. Now when I set it up, I'm going to use it now a calculator, correct? And we will find all of these coefficients using a calculator. So for this part, I will write over here, use calc to calculate the coefficient. Okay, ready, set? Now everyone, let's try. We are going to start with x to the 9th plus, and we use our button on the calculator, yes? We are choosing, depending on your calculator, again, remember how it works. We are choosing, start with 9, in my case, you use your calculator. Mass, probability, combination of 1, correct? And gives me 9. So next coefficient needs to be 9, x to the 8th y first, and you keep going. So look what I'm going to do. If you have calculator like mine, everyone pay attention. I will just go up, copy, paste, and change this to 2. Can you see? So I'm saving time. So next one needs to be 36, x to the 7th y squared. Moving up, copy, paste, change. 84, x to the 6th y cubed. 126. And remember, it's going to be symmetrical, so soon it will go down. So now I know 126 x to the 4th, x y to the 5th, plus 84 x to the 7th, y to the, x to the 3rd, y to the 6th, plus 46 x to the x squared, y to the 7th, plus 9 x y to the 8th, plus y to the 9th. And this is your expansion. Make sure that all terms are positive, correct? You will have one problem like this on your test. But this is easy because your first and second term do not have any coefficients. We are going to practice when they do have. Then it becomes more complex. Okay, how are we doing so far with all of these patterns? Make sense? Make sense? Okay. So when is your homework due?
Tomorrow.
Thank you so much. Tomorrow midnight, correct? So I cannot expand it. Okay, let's look at our next problem. A little bit more complex. Why it is more complex? Because my coefficients in the first and second term are not the same. It's not 1, it's now negative 1/2, correct? So when I will say second term, now when I will say first term to the 6, y, let's say 7, then you need to put parentheses around now here. And because it's minus, everyone, what do we need to remember? Even terms needs to be
negative.
And because I already know even terms must be negative, when I plug over here, I will have 1/2 b to the 7th, and then you need to use properties of the exponents, correct? So this part, it's a skill-based calculator is not going to do it for you. You will be able to find the coefficient over here. I don't know, let's say coefficient. But you then need to multiply coefficient by 1/4. Make sense? So this is when problem become more complex, and stay on task, be laser focus is the key. Set everything by hand first. Okay, let's try. Ready, set? So we have degree of 5, correct? I'm labeling. This is my first. This is my what? And moreover, I make a note for myself. Even terms must be negative. So I will just put minus and carry everything else positive. So let's start with the expansion, correct? Let's start with the expansion. According to the expansion, how many terms will we have?
6.
Write it down. So first one is first term to the 5th, correct? Yes? Then we start with the exponents, so then I can figure it out the right combination formula. So a to the fourth. Yes? Now second term, everyone pay attention, put parentheses around. B over 2 to the what power? First, therefore over here, coefficient, we will choose group of 1 out of what? 5. Are we good? And because it's a second term, as I said, instead of carrying this here, can you see? I immediately will put what? Minus. Because it's a second term, makes sense?
Okay.
Otherwise, you need to carry that negative and simplify, and you will make mistake with the signs. I will make over here a note, this is my second term in the expansion. Now third one needs to be positive, correct? Yes? Now I go with coefficient and exponents first. A cubed, first term cube, goes down. Second term, power goes what? Up. Therefore, we are looking for combination. 2, group of 2 out of what? 5, and because it's a third term, it needs to be positive. Do you agree? Now fourth term, everyone pay attention, I put negative, yes? Correct? And I don't worry about negatives anymore. First term power goes down. Second term power goes what?
Up.
Up. Then when I know powers, I know that I'm looking for a group of 3 out of what? 5. And this is the fourth term. Therefore, coefficient must be negative. Now fifth one, coefficient needs to be what? Positive. So power of the first term goes down, power of the second goes up, and now I know that I'm looking for combination of group of 4 out of 5, and the last one, second term, so fourth, fifth, sixth, correct? 6 needs to be negative.
Yes.
Fifth, sixth. It would be second term, b divided by 2 to the fifth power. Now when I expanded everything and I wrote everything by hand, this is the most difficult part, talk through the process. Now I'm ready to simplify, correct? Okay, so be careful, because all of this needs to be simplified in an order of operation. Power is what? First, correct? You cannot multiply before you raise to a power. So this needs to be simplify. This needs to be simplify, use the properties of the exponents, simplify. And when I say simplify, this is what I'm looking for. When I have a fraction and I raise it to a power, I need to raise numerator and what?
Denominator.
Denominator to a power. Okay, let's try. Keep going. So a to the fifth minus. Now we are going to calculate, correct? This coefficient in front. So we go 5, and I need 1 out of 5. Gives me 5, yes? 5. A to the fourth times b over 2. Any questions so far?
No.
Okay. Now this is my second term, I will need to simplify. Plus, now I'm looking for a coefficient. So I'm going to copy and paste and change it to 2, gives me 10. A cubed. And now be careful, it's b squared over 4. Do you agree? I'm labeling my terms so I don't mess everything up. Now minus, we need the coefficient for group 3 out of 5, also gives me 10. A squared. Now b cubed over 8. gives me 5, 8, b to the fourth, 2 to the fourth gives me 16, correct? Minus b to the fifth over 32. Now double check again that every even term is negative. Second, fourth, sixth. Now I'm going to simplify everything. Yes? Now everything needs to be simplified again. Every term. So we start. A to the fifth minus 5 over 2, correct? I will leave it as a fraction. A to the fourth b. Any questions where I got this? Because 5 times 1/2 or 5 divided by 2 gives me 5 over what? 2. You do coefficients, then you do exponents, yes? Now I'm moving here, everyone look. I have 10 on the top, 4 on the bottom. I must reduce by what?
2.
2. So this gives me 5. This gives me what?
2.
2. So will give me 5 over 2a cubed b squared. Any questions so far? Moving on. 10 and 8 are divisible by 2 again, correct? Gives me 5, gives me what? 4, so gives me negative 5 over 4a squared b cubed. 5 and 16 cannot reduce, gives me 5 over 16 apple banana to the fourth minus, and I will put coefficient first, negative 132 banana to the fifth. And I am done. This is my expansion. Can you see how problem went from just patterns? Now to pay attention to properties of the exponents, how to simplify fractions. We have one more crazy one. Okay, how do we feel? Can we tackle it? Let's try. So let's look at this one. Illustrates that expansion of the difference, and we already discussed this, correct? Has negative, so difference of two terms, that expansion has signs that will alternate. But what you need to remember that the negative even terms will be what?
Negative.
Negative. I like that better than just alternating. So negative, the even terms must be negative. So now let's look at the next one. And look, lower power, more complex it becomes. Can you see? Because now my first term, it's not just x. It's 3 times 1 over m squared, correct? So I'm going to label. This is my first term. So everywhere where I will say first term, you need to put parentheses around, correct? And simplify. My second term has more than one base, so remember properties of the exponents. When you will raise to a power, you need to raise each of them. And moreover, everyone pay attention, it's a difference. So I make a note for myself. Even terms are negative. Therefore, my calculations are going to be simpler. I don't need to carry negative bases and pay attention if my answer is going to be positive or negative. Okay, how are we doing? Good, good, good? Okay, let's try. Why did they tell me that m needs to be greater than 0? First of all, because this is irrational, correct? Can denominator be 0? No. So it cannot be 0. Moreover, it's a square root, therefore your radicand needs to be greater or equal than 0. But because of this, it cannot be equal 0, correct? So this is gives you idea of the domain for this whole expression. Are we good? Okay, let's move on. So I will rewrite 3m squared minus 2 square root of m to the fourth power equals. And I'm starting. First term to the fourth, correct? And when I say first term, remember you put your entire piece. Now second term needs to be negative, yes? I start with the exponent. So first term power needs to go down. So 3m squared is going to be to the third power. And the power of the second term will go up. So it would be 2 square root of m to the first power. Therefore, my coefficient, we are looking for the group of 1 out of what? 4. Any questions so far where I got? Good, good, good. Moving on. Third term, do I need to put plus or minus? Plus. Now we start with the exponents, correct? First term power needs to go down. Therefore, it's going to be squared, correct? And the second term power needs to go up, so it would be squared. Now remember, we are looking for the power of the second term, therefore we are looking for the group of 2 out of 4. Now fourth term, my sign needs to be positive or negative? Negative, yes? So I will move it to the another row. So negative, therefore, we are going to have power of the first term goes down, so 3 over m squared. Power of the second term goes up, so it would be cubed. Therefore, to find the coefficient, we are looking for combination to choose a group of 3 out of 4. And now fifth term, last one, correct? We have the second term to the fourth power. Now when I set up everything by hand, I'm ready to use properties of the exponents and a calculator to calculate the coefficients. So we start. 3 to the fourth, correct? 3 cubed gives us 27, 3 to the fourth, 81. 81. And m squared to the fourth, we multiply powers, correct? 2 times 4 gives us m to the fourth. And I will write these properties of the exponents here one more time. When you raise a fraction to a power, you raise numerator and what? Denominator. When you raise more than one base to a power, then you raise each of these bases to this power, because I'm going to apply this rule here, correct? Yes? Also remember, if I raise square root or any power root, when exponent matches the index, you cancel it what? Out. Correct? Yes, yes, yes? Yeah? Oh, yes,
Yeah.
I said 8 and put 4, yes. Okay, moving on, correct? So we are looking for a combination. Copy if you have a calculator like me, this is the fastest way. Group of 1, and we have 4. Negative coefficient. Now pay attention over here. 3 cubed gives me 27, correct? M to the 6. Now 2 times 2 square root of m. This is my second term, this sack of potatoes. Now moving to the third one, plus. We are looking for a combination. Group of 2 out of 4 gives me 6. Now simplify. 3 squared gives me 9. M to the fourth, correct? And now look over here, I'm using properties of the exponents. 2 squared gives me what? 4. And square root of m squared gives me m. Do you agree? Good, good, good. Moving on. Negative. Fourth term. Group 3 out of 4. We have 4, so coefficients are going to decrease. And now we have times 3 over m squared. 2 cubed gives me 8, and I will have a square root of m cubed. Plus 2 to the fourth gives me 16 square root of m to the fourth. Now I'm going to simplify each of these terms. And everyone look what I see. Can you see that I have m to the 6 and I have a square root. And this is where I'm going to change the square root using the rule to rational exponents. M over n, and then when I have exponents, I will simplify my degrees, correct? So this is important. Every radical, I'm going to substitute over here 2, and over here 2, and I'm going to simplify everything and reduce whatever I can. Okay, let's try. First term we have 81 over m to the 8th. Yes? Now look, 4 times 2 gives me 8. 8 times 27, yes, gives us what? 8 times 27 gives me 216.
Yes.
216. And now look what I have. I have m to the 6th on the bottom and m to the power 1/2 on the top. Yes? And I'm going to use here now properties of the exponents in my next step. To divide exponents with the same base, I need to keep the base and subtract powers, correct? Yes, yes, yes? So 1/2 minus 6, it's what I'm going to do, yes. 4 times 2 times 27. Yep. Okay, moving on. Plus 4 times 9, 4 times 9, 36, 36 times 6, correct? 36 times 6 gives me 216 again. 216, and now look, m to the 4th on the bottom and m to the 1st on the top, and again I will be able to divide my exponents. Now 4 times 8 gives me 32, 32 times 3 gives me 96. 96, everyone pay attention again, m squared on the bottom and m to the power 3 over 2 on the top, and I will be able to use properties of the exponents to simplify, correct? Now last one, plus 16, m to the power 4 over 2 that I can reduce and will give me just m squared. Now I'm going to simplify everything because I need the simple form. And I have 81 m to the 8th minus 216 over, and we can subtract fractions. I will do it here on the board. So I need 1/2 minus 6, correct? Yes? So I will multiply this times 2, and I will have 1 minus 12 over 2, correct? Will give me negative 11 over what? 2. Now, if I have, what is the letter? M to the power negative 11 over 2, according to the rule, when I have a negative exponent, I need to drop it to the bottom of the fraction. So this baby now will go on the bottom of the fraction with the positive degree, correct? So it would be m to the power 11 over what? 2. Positive. You must have positive exponents. Now m and m to the 4th I can cancel out, and I have 216 over m cubed. Now I have negative 96. And I'm going to do the same on the board. I will subtract. We have m to the power 3 over 2 minus 2, correct? Yes? So we need to multiply this times 2, gives me 3 minus 4 over 2, gives me negative 1/2. So m to the power negative 1/2, Now we'll go to the bottom of the fraction with the positive, correct? Yes? So it would be negative 96 over m to the power 1/2 plus 16 m squared. And this is my final answer. Pure skills, correct? Just flow from one topic to the other. Okay, let's try next page. Oh, this is it. Awesome. So now question is, if I'm not asking you to expand and create full expansion, correct? What about if I will ask you, can you just find a coefficient and a variable part of the 1, 2, 3 of the fourth term? Can you see? Just of the fourth. I don't care about everything else. Do I need to do all of this? No. I will just focus on one what? Term. And the question is, how can I do it fast? Without even doing this expansion like we started from beginning, correct? Because if I ask you for 87 degrees, correct? I don't need to do all of this because it will take you so long, correct? But knowing the rule, I can focus on 60th term. So let's look at the rules. And these are the rules. If you are looking for the k term of expansion, and we are looking for a specific term, so we are looking for a specific term to make this process easier. Is it blurry again?
Yeah, a little.
Okay, better? Okay, perfect. So, in order to understand how it works, again, we are looking for the patterns, yes? So let's start with the step number 1. Step number 1, to find the specific term, we are going to follow the steps. Step number 1, we are going to find, first of all, the value and exponent of y, correct? How do we do this? It would be, if I'm looking for the fourth term, it would be 4 minus what? 1, correct? Okay, one more time. If I'm looking for the fourth term, it would be whatever you term have minus what?
1.
1. So it would be k minus 1. Oh, what? What's wrong? Oh, magic. I'm gonna stand like that. So, this is an exponent of what? Of what? First or second term? This is an exponent of what? Second exponent. Way to go. Is the second exponent. Now, because we know that the sum of all exponents needs to be equal the degree of your binomial, correct? Yes? So remember, the sum of these terms needs to be equal the degree of your binomial, correct? So then I will be able to find the degree of the first term, correct? And how can I do this? The exponent, okay, subtract the exponent found in step number 1 from the degree of your binomial to obtain the exponent for the first term in the binomial. How are we doing so far? Can you see it's common sense patterns? Then I'm going to determine the coefficient of this term using the exponents as we discussed. You are looking for the group, correct, of equal to exponent of your second term out of group of n, your degree, correct? And then you are going to do just everything that we just did for one term. The most difficult part is to do this and understand that the sum of this, sum of exponents, equal degree of a binomial. So sum of the exponents must be equal degree of the binomial, that is your n. Determine the coefficient using exponents found in the two steps and knowing this n. Okay, let's practice. Because it's easy, it's just common sense. Question is where to start. So let's look. Find the particular term of binomial in expansion, and binomial always will be given to you. So from here, I'm going to analyze what is given to me, and I immediately know n equals 10. Do you agree? Yes? My first term equals a, and my second term equals 2b. Why it is important? Because when I say second term, you need to put parentheses around, then you need to raise it to the power, correct? And we are looking for what term?
7.
Seventh. Therefore, k equals what? 7. So this is my analysis. Now when I analyze everything, the rest is easy. Step number 1. We are going to find the exponent of the second term. How? 7 minus 1 gives me what?
6.
6. So I will have 2b to the 6th power. Any questions so far? Therefore, step number 2. Find the exponent of the first term. How? 10 minus 6 will give me what? 4. Therefore, I will have 8 to the 4th. These are my conclusions. Now, when I know these degrees, I know how to find the coefficient. Step number 3. Use exponents to find a combination. For the coefficient. For the coefficient. And I know that now I'm going to have my second term power is 6, so I'm looking for the group of 6 out of how many? 10. Then I need my first term, correct? A to the 4th. Second term, 2b to the 6th. And I'm going to simplify everything. Let's calculate. So we have a group of 6 out of 10. Mass. 6, correct? And I got 2 10. Gives me 2 10. 8 to the 4th. Now properties of the exponents. 2 to the 6th, it's a big number. Gives me 64. B to the 6th. Simplify. 64 times 210 gives me 13,440. A to the fourth, B to the sixth. Sorry, I'm going to zoom out. And can you see this process is much simpler than finding every single coefficient for every single term in that expansion. But you need to start somewhere, correct? Okay, how are we doing? Good? Okay. So please rest today and start tomorrow, and I will see you on Thursday at 6:40. Do you have any questions about your review? Yes. So we can do it together. What did you get there? So this was your problem, I wrote it on paper. So we have x squared over 36 plus, sorry, y squared over 9, correct? Equals 1. And we need to find the simplicity when it's ellipse. It was number 11, because I remember, number 11. Yes? Because it is an ellipse, because I'm looking at the sum, yes? Different coefficients. Remember, I'm going to go it. It's going to be horizontal major axis, yes? 6 goes to the right from 0, 6 goes to the left, yes? So this is my A. And my B is 3, so I go 3 up and 3 what? Down. And my C is going to be within the ellipse. Do you agree? Yes? Because C is shorter. We need to use the formula. C squared equals what? A squared minus
B squared.
Where to go? A squared minus B squared. And we go 36 minus 9 gives me 25. Therefore, C equals what? 5. Do you agree? Now, because it's an ellipse. Yeah? And we talk about this eccentricity. We talk about distances, so I don't need to take a negative value, correct? So, eccentricity is going to be C divided by what? A, yes? Yes, yes, yes? And it would be 5 over what? 6, done. So you can put the answer.
36 minus 9.
Yeah, is it 25? Is it 27? What is that? 27? Okay, so 27, yes. So then it would be square root of 27, yes? So we will have square root of 27 divided by 6. Let's discuss. Square root of 9 times 3, yes? We can break it down. Divide by 6 gives me 3 square root of 3 divided by 6 gives me square root of 3 over 2, correct? Yes? Okay, so we got square root of 3 over 2. Good? Any questions? You don't have questions similar to this? Yeah. Yeah, it's 27. Can you see? So common sense. Any questions so far? Any other questions? Okay, remember when we talk about eccentricity, you talk positive, take positive values because it's distances, yeah? Okay, thank you guys, you're free to go. I appreciate you. And I just emailed, like I said, at the beginning of the class, so I will see what they will say. And maybe I will ask you to do evaluation if it's necessary. If not, we will not. Okay, thank you guys, drive safely.